guys, today we're going to be covering L'Hopital's rule. Hopefully I spelled this right. Hopefully I spelled L'Hopital's rule right. Anyways, this is a rule for limits. So hopefully you guys know how to do limits before this. So you can denote limits as this or this, but I'll be choosing this one. Okay, so what L'Hopital's rule is, when a limit is equal to like an indeterminate form, so 0 over 0 here, then we differentiate both the top and bottom as respectively z of x over y of x. We differentiate that like that. So for using this example, what we're going to do is that for cases like, first I'll cover a simple case, as that is a more complicated expression. Let's cover this one. Limit x reaches infinity of 2x over 3x. This is equals to infinity over infinity, which is an indeterminate form. But real quick, I'll show you what an indeterminate form is. An indeterminate form is any of these forms. So 0 over 0, or infinity over infinity, infinity minus infinity, infinity over 0. Wait, I just forgot. Infinity over 0 is not an indeterminate form, it's just infinity. So any of these forms we can use L'Hopital's rule in. So now let's solve this. So now we put z of x as 2x and y of x as 3x. And now if we differentiate these, so z of x, pretty sure you guys know basic differentiation. Anyways, we will get 2 and 3 respectively. Why am I on pencil? What is that? Get 2 and 3 respectively. Because if you remember this formula, f of x is equals to x, f of x is equals to 1. And then 2 times 1 is 1, and 2, and then 3 times 1 is also 3. So now what we're going to do is that we're going to plug this back into the limit and evaluate it again. So limit x reaches infinity. Why is that a singular? What is that? That does not look like infinity. If x reaches infinity on 2 over 3, this limit will literally cancel out because there's no x in this. So this is equals to 2 over 3. So limit, why is this erased? What is going on? So limit x reaches infinity, 2x over 3x is equals to 2, not 3 over 2, 2 over 3. That is basically L'Hopital's rule. So let's cover that example we saw there again. Limit x reaches 0, x over x. So for this one, it's an indeterminate form 0 over 0. So for the indeterminate form 0 over 0, what we will do is that we first differentiate it, of course. So this will be 1 over 1 now. 1, as I already covered x6. And now again, why did I just write tt? What is that? Okay. Limit x reaches 0 on 1 over 1. The limit will cancel out again. Equals to 1 over 1 or just 1. So limit, not tt, what am I doing? So for 1 over 1 So for this limit, at x reaches 0, x over x is just equals to 1. Now, the limit is not always diminished. Let's try another one. Limit x reaches 0 of sine 3x over sine 4x. How would we solve this? Well, we would use L'Hopital's rule, of course, as this is just an indeterminate form 0 over 0, because sine 0 is 0. Remember that. We will find the derivative of all of these. So z of x is equals to sine 3x. Then I wanted you to take a moment and think about z of x be equals to. Okay, there you go. You got your moment to think. Well, in this case, use the chain rule. And according to the chain rule, this is 3 cos 3x. And in the y of x is equals to sine 4 or x. Using the same chain rule, we can deduce that this is equals to 4 cos sine x. Not 4 cos sine x. So what am I saying? 4 cos 4x. So, in this case, now what we will do, plug it back into the limit. And, oh my goodness. Limit x reaches 0. Cos 4 cos 4x over sine. There's no sine. What am I doing? But the 4 cos. Oh my goodness. You know what? Just ignore that. Pretend like that never happened. 3 cos 3x over 4 cos 4x. What am I doing? Goodness, what am I writing? Cos 4x. Here we'll get 0, 0. Here the 0. Long story short, we will get 3 cos of 0 over 4 cos of 0. Remember, cosine of 0 is always 1. So we'll get 3 over 4. I wanted to show you guys a little formula for anything that is in the forms of these. This doesn't really apply to L'Hopital's rule. If you see anything in the form of this and it leads to an indeterminate form. So wait, I spelled this wrong. L'Hopital's rule. What this actually is. What? Oh my goodness. What the formula actually is that limit of x reaches 0 of n1 sine x. No, it's actually. Oh my goodness. Why am I so this thing? Just ignore all them. How tired and I am. Side n1x over sine n2x is always equals to n1 over n2. As we just saw here. This was in the form of that and it led to n1 over n2. And this can also work for tangents. Just take my word for it. This also works for tangents after some secant stuff, okay? Of tangent n1x over tangent n2x is also equals to n1 over n2. Anyways, that is it for episode 1 of L'Hopital's Rule. L'Hopital's Rule is way deeper than you think. I'll make another video on it soon. For now, goodbye.